Hi guys, this is a video on number systems. The real number system. Hey. Oh yes. So real numbers consist of rational numbers and irrational numbers. Rational numbers basically means you can change it to fractions, while irrational numbers like square root 3 cannot be changed to a fraction, even pi. So those are rational. Now under rational numbers, there are integers, positive, negative zeros, and also fractions, okay? Now, one thing to learn, recurring decimals can be written in a short way, having a dot on the top. Now, for example, you have a recurring decimal like this, the two dots are above 3 and 1. That means it repeats from 3 until 6. Okay, the numbers between 3 and 6. So it's gonna look like this: 316, 316, 316, 316, 316. And yeah, it feels like the video is broken, right? Imaginary numbers is now going to be learned by you. So what are imaginary numbers? Imaginary numbers are basically numbers that gives you math error in your calculator. So for example, square root of -1 is what we call imaginary number I, letter I. Why do we have this? I think mathematicians don't want the idea that it's math error, so they want to represent it using notations, even though you cannot see it in real life. Or maybe, I'm not sure if there's any meaning to it. There's probably is, like it's probably used somewhere, I'm not sure. You can do your research on that, okay? So for now, I'll teach you how to handle imaginary numbers. Again, every time you see the letter I, it's square root of -1. Now we're gonna learn how to, oh yes. So complex numbers is a combination of real and imaginary numbers. So for example, if you have 2 here and 3i over here, this is the imaginary part, well this one is the real part, just for your information. I'm not really gonna go through these questions. You can just refer to the table or learn it by yourself. Now let's go to 44. Okay, so over here we have square root -33, right? Now if you separate into -1 times 33, that can be separated to square root -1 times square root 33. So the BI form for this is square root of 33, and we're gonna change square root of -1 into I. Alright, so this part here, square root 33, is a real number, but I there is an imaginary number. Now over here, we have negative square root -64. Do the same thing, -1 times 64. Square root of 64 is 8, so you can have -8 and the I next to it. Now a common question using I is with a power. Now there is a trick over here, is so for example, I is square root -1, right? If you have I squared, you're multiplying square root -1 twice. Now if you put this in the calculator, you would get -1. Then if you do I to the power of 3, you're doing it 3 times, and what you're gonna get is negative I. Yep, so -1, and then you multiply square root of -1 on top of this, you will get negative I. Now for I to the power of 4, you would get -1. Sorry, not -1, +1. So for here, if you multiply another I, you would have square root -1 times square root -1. That's going to be 1, +1. Now if you do it, now you will notice if you multiply additional I on this, you'll start back at square root -1. Okay, because I times 1 is just I. Okay, 1I is just I. So it goes in a loop, 1, 2, 3, 4, and then again 1, 2, 3, 4, and then 1, 2, 3, 4. So how do we handle this is, instead of multiplying square root -1 one by one, you're not gonna do that for 20 times, right? We can think of a smart way. If you divide 7 with 4, you would end up with a decimal. 7 divided by 4 is 1.75. Now 75 is the third one, because this one is power 1, right? 1 divided by 4 is 0.25. And then 2 divided by 4 is 0.5. Then 3 divided by 4 is 0.75. Then we have 4 divided by 4 equals to 1. Now, 75 here, 0.75, and this 75 will produce the same outcome. So that means, I should erase this. That means I should write negative I over here. That's how you simplify. Now for 13, let's do the same thing. 13 divided by 4 is 3.25. We're just going to look at the decimal. 25 follows the power 1. So power 1 means it's just simply I. Then 20 divided by 4 will be 5.00. This is basically 00. So that means it's related to, or the same answer as power 4 here. So we just simply write 1. Okay? So with a power on I, it's either this one, this one, this one, or that one. Okay? You don't really need to consider 5 anymore. Now think about this. 5 divided by 4 will give you 1.25, right? So this, which is I, is the same as this one, which is also I. So they're both the same. It just goes in a loop. You don't need to continue finding the other powers. Okay, so just real quick here. Real part here is 2. Imaginary part here is -4, because -4 is next to I being multiplied to I. Sometimes there is no imaginary part. For example, here, square root of 81 is just simply 9. If there's no I, then it's 0. Okay, how many different questions are there? Same here. Let's just do one of the newer ones. What's this? Express the results in the form of a plus bi. Okay, let's see what we can do here. X is equals to square root of -36. Oh, you're just going to separate into plus or minus, don't forget. Plus or minus 36 squared 36 is 6, right? Now what remains will be the negative over there, which is actually -1. So square root of -1, but instead of writing square root of -1, you would write I. So the answer here is plus or minus 6i. Okay, last type of question. Now over here, they said this is equals to this, so you can do something called like terms. The real part is equals to the real part here. So if you do 2a equals to -8, you can solve a -4. The imaginary part is the same as the imaginary part there, so 4 is equal. You don't have to include I, you can. If you include I, you're just gonna cancel it anyways, like that. So 4 is equals to b minus 1, and that is b equals to 5. So those are your two answers. I think that's most that you have to know in this section. And good luck. Goodbye.